Super excited to be here today. I'm looking so much forward to giving you a little insight on 3D printing. So how are you? Your head spinning? Yeah? Yeah. The bio and medicine guys tends to have that effect on you, right? And if we can keep a little secret just between the few of us, when I was at SU back in 2010, I didn't really get it. I didn't really understand everything. I'm a business guy. And all this tech stuff was very hard to grasp. It took me a while to get it in. But the important thing is not to understand every detail there is on all this wide array of technologies. It's to grasp the concept of how this is going to change our world, our society, and our civilization. I think that's the most important thing. So I'm here today to talk about 3D printing, digital manufacturing. And that is really the most important topic of this summit. Because that's the notion of creating what I want, when I want, and where I want. That's basically information enabling our physical world. So all we've seen in music and media is coming to the physical world with 3D printing. And that is kind of huge. Still a very small market. I think it's market cap on 3.1 billion, so very small. But be aware, 3D printing is growing at a tremendous pace. So, why is this happening now? First of all, the technology has been around for some years now. And in 2007, the patents for the basic technology ran out. And that fostered a wide amount of innovation within this field. Then, of course, as you heard, the abundant access to computing is really important. And that made the prices drop radically. So in 2007, an industrial 3D printer will set you back $18,000 US. And yes, the industrial 3D printers are still very expensive today, but at the same time, we've seen a new area of home 3D printers that goes for a whole different price. It came to the open source community, the do-it-yourself environment, and that has really fostered a lot of new innovation across this field. I want to show you a few examples of the use of 3D printing today, and after those, we're going to go back into more of the technique behind the 3D printers. But let's start out seeing some really cool things. The first one I want to show you is from Formula 1, a sport where small marginals is the difference between success and failure. Here is from the Renault team using 3D printing in their wind tunnels to do fast iterations on the design of their cars. So this is a way of iterating really, really fast and building the perfect vehicle. Hearing aids has been 3D printed for quite a while now. So we all have different unique ears, and for a hearing aid to work, you need it to be fitted perfectly for your ear. So you do basically you do a scanning, and then they print a hearing aid especially made for you. We see this coming to the consumer electronics as well. So here's a company where you take a picture of your ear, holding up a coin for measurement, and in a few weeks they'll send you a pair of in-ear for listening to music that'll fit perfectly to your ear. So that's an interesting move there. So more in the industrial side, this is from General Electric. They created this fuel nozzle for jet engines. The old one consisted of 20 parts that had to be put together after production. This one is printed in one part, one production run with a 3D printer. And it also tells us something about the durability of 3D printed objects. That this fuel nozzle will actually be able to handle the stressful environment in a jet engine. Then there's the container ships. And thinking of 3D printing, you might want to say, those are the ones being disrupted by 3D printing. And that might happen in the future, but while we wait for that to happen, they are actually using 3D printers themselves on board of those ships. So they have like a mini factory, a printer like that, and that printer is rather interesting. It's a combination of 3D printing and milling. So the machine does both. It's combining this new technology with existing production technologies. And it creates spare parts for the engine, so the ship doesn't have to wait for spare parts in case of an engine failure. A lot of SU companies has taken on the challenge of improving housing in case of emergencies, when you need to create a lot of new houses very fast. This is a Chinese project for 3D printing houses. And yeah, it's still not looks like a house you want to live in, like for real, but the technology is there and it's evolving very fast. Just to show you that you can print like really big objects with a 3D printer today. Then there's the 3D printed car. You've seen this car? This is Local Motors, small micro factory that created this car at the motor show at Vienna last year. It took them 44 hours to print this car. And just 2 weeks ago, they announced on their website that they are now accepting orders for this car. And I don't know, I come from Denmark, the climate nuts to a car like that. So, but the thing is, they want to iterate on this car every 2 to 3 months. So a regular car company iterates every 2 to 3 years because it's tremendously expensive to reconfigure your product line. But when you 3D print that car, it goes really fast. It's all in the software, it's all digital. So be aware of the 3D printed car. Daniel talked a lot about medicine. I just want to show you a few examples. On your top left, there's a really interesting team at Princeton printed an ear and put in super artificial electronics for super artificial hearing, so you'll be able to hear much better. But also the blood vessel is an interesting first step towards printing real tissue. The picture below is from a Japanese company printing body parts for training. So when you go into open surgery, the doctors can rehearse the operation before on these artificial objects. Prosthetics, you heard Nigel's story. Prosthetic is also something that are starting to move into the 3D printing area. On the video, you see a kid who has a low-cost mechanical 3D printed hand. And if you notice, there were some small claws on it. So that's the Wolverine claws. So he can actually start to feel cool about having this handicap and this very accessible technology. Actually, some of the people who created this from the tech shop moved this into another area, to the people living in refugees camp in Syria who suffered from the war and didn't have access to this. This is a beautiful example of what Rob was mentioning about democratization of technology. Bringing this cheap technology to places like this is really important. So a price for a simple mechanical prosthetic is about $3,000. But using a 3D printer and a 3D scanner, they're able to create these low-cost prosthetics for $200 to $300. So that's a huge change. And the last example is another SU example. I went to class with these guys, made in space. They set out to do 3D printing in zero gravity. And just in the last few months, they put their printer on the International Space Station, and they printed the first man-made object that had never been on the planet Earth. Well, how about that? That's real cool. So, what brings this together? How's this tied together? The need for fast iteration, personalization, and then the the places where the current supply chain can't reach, the hard-to-reach places. That is what brings 3D printing, makes 3D printing interesting as of today. I don't know how many of you have seen or even 3D printed something for yourself. This is an example of a 3D printer printing a wrench. This is a little upscale. It'll take about half an hour, 45 minutes to do a print like this. What you're noticing printing this wrench is that it's printed in one piece. So a wrench like that basically consists of three pieces. The big piece, the small wheel, and the slider. But we print it out in one piece. So when you 3D print something, you don't need to assemble it afterwards. And that means you can also 3D print stuff that couldn't be assembled if it were produced using regular techniques. So that's one thing, no need for assemble. The other thing is complexity. We all got used to writing with our inkjet printers at home. It doesn't matter whether you were printing out a school assignment for the kids or a great piece by Shakespeare. It's just ink on paper. The same goes for 3D printer. The 3D printer doesn't care whether it's printing the yellow button in the middle, it's very simple, or the other stuff. So complexity is free. Complexity is free, we haven't seen that yet. And you can now print in 300 plus materials. The number's getting up very rapidly. On your left again, you see the small titanium pulley wheel, a Danish company, that by making that wheel hollow, they put off 25% of the weight of that wheel. And if you're an elite triathlete, then 25% weight reduction, that gives about 2 grams. Kind of is really important to you, I don't know. It set you back $1,000 for a pair of pulley wheels, so it's still very expensive, but an interesting project. There are basically 3 main techniques for 3D printing. The selective laser sintering, you might have seen the people pulling things out of powder. That's this one where you use energy lasers and build stuff within the powder, melting the powder to an object. Then the one I showed you with the wrench, that's diffuse deposit modeling, where the nozzle ejects a little filament in small beads, building the model layer by layer. And the last one uses a liquid with laser lights to harden the liquid on the surface, building also layer by layer, but in the surface. That technique is used for very small items. I'll show you one of those later. Then there's how to get things in the printer, the software that runs it. It's getting very easy. It used to be very hard. You need a long education to be able to work with computer-assisted design, but it's getting very easy. The Thinkercad is actually a piece of software that my 8-year-old daughter used at her school. So it's getting really accessible to build stuff that goes into the 3D printer that you can then print. Here's another example from Autodesk. If you don't want to draw things yourself, you can copy things from the real world and have them printed afterwards. This is a really cool app you can download and play with. What it basically does, it takes a lot of pictures and then upload them to Autodesk server and then stitch it together to create a 3D model of the things you want to print. So the copy machine is already here. You have learned through these days that no technology is just for the fun or the good things. There are also challenges along with technology. And here are a few from 3D printing. Piracy or copy protection. How can we protect our objects or resources when they can all be copied with a mobile phone and then 3D printed? So this is a major issue that are still unsolved. There is one guy at SU called Andre Wegner. He's built this company called Authenticize. They have a saying on this. So what they're building is a platform that enables you to stream your designs directly to the printer. So the consumer doesn't have to keep the file on his computer to be copied, etc. You could just stream directly to a printer. So that's a new way of thinking and using of these printers. Very interesting project. There are way too many failures still. If you play around with a printer, you usually end up like this. It's a mess. So we need to have better quality printers you need to have fewer errors. And that goes back to standardization. We have no standards within this sector, and they need to be built. Also a great challenge. Then there's this guy, Cody. You heard of him? He 3D printed a gun. He drew it, 3D printed. Only thing he needed was a nail and the bullet, and then he could fire a gun. And then he put the drawings up online, so everybody with a 3D printer basically had access to weapons. And this tells us something about the dangers of exponential technologies. So the one person's ability to create damage or harm is growing exponentially. And this is Cody's case is an example of that. So one of the perspectives I see here is the changes this will bring to production. We all live with supply chain, and it's a mess. I mean, we just got used to it. Long lead times, high cost standardization, big warehouses, et cetera, et cetera. But when we have 3D printing and add this to the equation, we'll have what I'd like to describe as distributed manufacturing. So we will move the manufacturing to where the item is needed. And this is the perspective I'm seeing. And this means, as a company, your paradigm is shifting from efficiency of scale, how can I put my product through that supply line as fast as possible, to a paradigm of design and iteration and collaboration with your clients. So this is an interesting shift, and it's not easy. So let me end up by looking a little bit into the future. What's the next thing that we'll see within 3D printing? First of all, the food printers. They're really cool, but I heard the food tastes a little bit strange. So the most important, the most known one are the sugar cubes at the bottom. They taste a little bit burned, I heard, but they're getting there, and it's really funny. So 3D printing of food, keep your eyes up for that. And when we talk about food, I would love to mention yet another US company called Mudita.Digital. These guys at SU are using a combination of growing and 3D printing meat. Right now they do skin, leather, perfect leather, but they're working onto the meat. Because if we want to be 11 billion people on this planet, and we want to eat meat, we need to figure out another way of producing that meat than from carving it from the side of animals, right? And that's what they set out to do. Really interesting project. Then there's the speed of printing. It's too slow, and we need to figure out a faster way of 3D printing. So this is a Google project for their new phone, the Google Ara, where they, instead of moving the nozzle across the object, they're moving the object under numbers of nozzles to create a faster production line. So we see different attempts to have more speed to the 3D printing production. This printer came on the CES, Consumer Electronic, this year. It's a 3D printer that combines two types of filament so it can print simple electronics. And here you can see some examples of printing electronics. And it's really interesting that we can do simple stuff, printing sensors and electronic in 3D printers. Then I promised you to talk a little bit about the small-scale printing. This picture has been on the internet for a few weeks now. This little figure here is placed on a human hair, just to give you a sense of how small it is. So it's standing on a human hair. You also maybe seen this one, a 3D printed car on the nanoscale. So why? I mean, we cannot drive in cars that are that small, but this goes for medicine. This is how we bring the computers inside our bodies. They will produce the things that Daniel talked about, that when we need to have those evolve the way we use electronics within our bodies, we will use this type of nanoscale printing. So let me start to finish up here and end where I started. The idea of 3D printing, what I want, when I want, and where I want. This is a concept only, and this is way out in the future. But this is the idea of creating a 3D printer that using a nanofactory to print from the atom level, building what you want. And we look into a future where this is possible. You can imagine the number of things that will change in the way we do business, the way our society and economical systems are working. So here you see the nanobot building bigger and bigger parts, creating this laptop computer basically from the bottom up. It's a concept. Let me end this talk by showing you a little video. When I see a picture of my daughter on her first school day, it brings back memories. It attaches to emotions that I have. If you're blind, you're not able to see pictures. Hence, you're not able to recreate the emotions that are in those pictures. So here's some guys who used 3D printers to create a project for blind people, having them re-experience the emotions they had prior in their lives.
If I could touch the picture, I could make the memory tangible again.
Mamma mia, mi sono sempre chiesto questo logo come fosse, adesso finalmente posso vederlo.
And I can find myself in the picture. I never saw myself in a picture.
Ay, ella tiene la mano así, como en la cara así.
لما توفي أبي أنا كان في عمري 6 سنوات أو 5 سنوات.
I remember this hat.
There was a table in the foreground. Yeah, this is it.
Nos estamos dando la mano, eso sí que no lo sabía.
كان يحملني هكذا السلام عليكم يا ابن الحبيب.
Ed è incredibile perché sicuramente non basta una ora per capire un disegno di questo tipo.
The world in my palm. Wonderful.
Thank you very much.